To start this problem, I simply want to plug in what I know about f of x and g of x so that I can look at this and decide what algebra I need to do. So for this problem, if f of x is greater than g of x, I know that f of x, which is 2x squared, must be greater than or equal to g of x, which is 5x minus 2. So here I'm comparing, through an inequality, a couple of polynomials. And to solve this type of inequality, I want to compare everything to 0 first. So I'm going to get everything over on the left-hand side. I've got 2x squared. When I subtract 5x from both sides, I'll have minus 5x. Add 2 to both sides, plus 2. Must be greater than or equal to 0. Once you have everything compared to 0, you want to look for the critical points. And that's going to happen when the polynomial is equal to 0. So since that's quadratic, I'm going to try factoring this. 2x squared, the only way I can factor that is to 2x times x. And then I want to plug in factors of positive 2 that will somehow get me negative 5x. And that's going to require that I do 2x minus 1 and x minus 2. This has to be greater than or equal to 0. So my critical points from here, if I set this equal to 0, add 1 to both sides, divide by 2, I'll get x as a half. And when I set x minus 2 equal to 0, I'll get x is equal to 2. So from here, I'm going to make a chart to look at the signs of the factors, and then I can come back and look at the signs of our original polynomial. So I want to know what the sign of 2x minus 1 is, what the sign of x minus 2 is, and I'm going to do that between the critical points for our problem. So the smallest one is a half. I'm going to go from negative infinity to a half, from a half to 2, and then from 2 to infinity. So plugging in a test point, if I were to plug in negative 60, 2 times negative 60 minus 1, well, that's negative. Plug in x equals 1. 2 times 1 is 2, 2 minus 1 is 1, that's positive. And plug in a huge positive number here, I'll get a positive number. If I plug in some other numbers, I would see that I'll get a negative, and a positive. And then when I multiply these together, 2x minus 1 times x minus 2, I'm going to get 2x squared minus 5x plus 2. 2x squared minus 5x plus 2. And I really don't care about any values. I just want to know, is that polynomial going to be positive or negative inside of each of these three intervals? So between negative infinity and a half, I'll multiply a negative times a negative, which is a positive. Between a half and 2, multiply a positive and a negative, I'll get a negative. Between 2 and infinity, I'm always going to be multiplying a positive and a positive, which will give me a positive. And our inequality said that this polynomial here must be bigger than or equal to 0. So in this region here and in this region here, my polynomial is positive. It's bigger than 0. So I know that my solution set then is going to be both of those intervals, minus infinity to a half and 2 to infinity. Okay, if I'm in either one of those intervals, I'm going to have a solution. And notice that I left off the endpoints here and here. To determine what I use here, I need to look at the original inequality. My original inequality allowed for the polynomial to be equal to 0, which happens when x is a half and when x is equal to 2. So if x is a half, this is equal to 0. I include that point. Likewise, I include this point.